Look at number 5 real quick. Calculate the following values for this 10 kilogram falling object. So it's simply just falling, reaches the ground. We're going to calculate all this. We know at the top the velocity is 0. Starts the initial velocity, the initial speed is 0. Pretty simple to calculate potential energy at this point. Potential energy is simply mgh, which if we plug everything in, that's 10 times 9.8 times the height, which is 200 meters. Meters is what we need, so we're just going to keep it like that. And 10 times 9.8 times 200 gives us 19,600 joules of energy. Right? 19,600 joules of potential energy. Kinetic energy, since there's no velocity, there will be no kinetic energy at the top. And the total energy is the addition of these two. And the total energy for this system is going to be 19,600 joules. So all of it is potential energy at this point. Let's come down here to the middle, right in the middle of the fall, where now the height is 100 meters. So again, we can simply calculate potential energy using that. mgh is potential energy, mass is 10, g is 9.8, and the height is 100 meters. 10 times 9.8 times 100 will give you 9,800 joules. We don't quite know the kinetic energy yet because we don't know the velocity, but we do know the total energy because the law of conservation of energy says that if this is the total energy here, then it also has to be the total energy here, and quite frankly, it has to be the total energy here. You can put that on all three of those because conservation of energy says that the total energy doesn't change. I should be looking more at you guys and less at the screen and the paper, right? How you doing? All right, so 9,800 joules is the total energy here. Now, how can we figure out velocity and kinetic energy? We can't know kinetic energy yet. Well, technically we can. I take that back. We can know kinetic energy. If we know that this is the total energy, and the total energy is potential plus kinetic, then we can say 19,600 equals 9,800 is the potential energy plus kinetic. Subtract 9,800 from both sides, and you'll get for the kinetic energy, it'll come out to be 9,800 also, 9,800 joules. So we can throw that right in here. 9,800 joules. And if that's the kinetic energy, remember kinetic energy is 1/2 mv squared. So 9,800 equals 1/2 mv squared. And the mass is 10. So 9,800 equals 1/2 times 10 times v squared. Half of 10 is 5. Divide both sides by 5. 9,800 divided by 5 will give you 1960, and that's v squared. Take the square root of that, and you should get v will come out to 44.3 meters per second. So we can plug that in right here, 44.3 meters per second. Alright, look at the bottom. Height is 0. If height is 0, potential energy also has to be 0. No more potential energy. Total energy is still this. So if potential energy is 0, then all of it has to be kinetic energy. So we can go ahead and plug in 19,600 joules right here for kinetic energy. And go our 1/2 mv squared again. So 19,600 equals 1/2 m, which is 10, times v squared. We're going to solve for v to plug it in here. 1 half of 10 is 5. Divide by 5. V squared, you get 3920. Take the square root, and you should get 62.6 meters per second for the speed. All right? Hope that works for you. Let's go to the back. Turn to number 7, and we'll work through number 7 very quickly. I'll work through number 7 with you. We have a 100 kilogram roller coaster. At the very top, velocity is 0 right here, so we know since velocity is 0, kinetic energy has to be 0. Therefore, all the energy up here at the top is going to be potential energy, which strictly depends on the height. So potential energy is mgh, and that's mass is 100 times 9.8, and the height is 10. 100 times 10 times 9.8 will give you a potential energy of 9,800 joules. All right. The total energy is the addition of these two. 9,800 plus 0 is 9,800 joules. Total energy. And that's going to be the same total energy for the other 2 points. Even though it doesn't have total energy, you might want to write it down here just to tell yourself. Total energy is 9,800 joules. Mass is 100 kilograms. At this point, the roller coaster is on the ground. There's no more potential energy because height is 0. Okay, so we'll put that in here. Potential energy is 0. And if the potential energy is 0, you know since the total energy is 9,800 joules, all of it now has to be kinetic energy, 9,800 joules. That's how you use conservation of energy to figure that out. And that energy has to equal 1/2 mv squared. That's all. That's how you calculate kinetic energy, and we can use this equation to solve for V. 1/2 mv squared, the mass is 100 times v squared. 100 divided by 2 is 50. So if we divide this by 50 and divide 9,800 by 50, I believe you'll get 9,800 divided by 50. You should get 196, and that's going to be equal to v squared. Take the square root of 196, and let's make sure we got this right, and you should end up with a speed right here of 14 meters per second. And let's look at the last one once again. Total energy must be the same at all points. 9,800 joules. 9,800 joules. Total energy. All right. Now, this is only 4 meters. 4 meters is now the height. It's not on the ground, so potential energy is not going to be 0. And it's not all the way at the top again. So we're not going to have all kinetic energy, or all potential energy rather. It's going to be somewhere in the middle. All right, so we got to do a little bit of work here. If mass is 100 kilograms and we know the height, then we can come up with potential energy. Potential energy is up here, is mgh. So we'll do the mass is 100 kilograms times gravity is 9.8 times the height, which is 4, and 100 times 9.8 times 4. When you do that, you should come out with 3,920 joules. 3,920 joules. Since this is the potential energy, there's still a lot more energy left that from this total energy, and that tells me that at this point this object is still moving, and I hope it is, because it needs to make it over this hill, because there still has to be some kinetic energy here to make up the rest of this 9,800. Alright, so to find that, we can simply subtract 3,920 from 9,800, and you should get 5,880, rewrite that, 5880 joules. So 3,920 plus 5880 will give you a total of 9,800 joules total energy. Equals a kinetic energy. Alright, and now that we have this, we can find our velocity from the kinetic energy. Because 5880 is the kinetic energy, and that has to equal 1/2 times the mass, which is 100, times v squared. Half of 100 is 50. Divide both sides by 50. 5880 divided by 50 will give you 117.6. That's going to equal v squared. Take the square root of both sides, and you should get a speed of 10.8 meters per second.